So Chan, you said, well, if they intersect, these two things should be equal to each other. In other words, I should be able to find a general point on both of these two lines that is the same. Yeah? So let's set them equal to each other. So I'll do intersecting over here. So I'm just going to literally set this equation equal to this equation. Now, are you happy that if I break it down into the ijk direction, okay? So I can say 4 plus lambda lots of negative 8, so that I could write as 4 minus 8 lambda, sorry, 4 minus 8 mu rather, should be equal to negative 2 plus lambda lots of negative 9. So that would be negative 2 minus 9 lambda. So that's my I direction. If I think about my j direction, same kind of thing, 2 plus mu lots of 1, so that's just 2 plus mu, should be the same as a plus lambda lots of 2, so a plus 2 lambda. And for my k direction, I'm saying negative 6 plus mu lots of negative 2, so negative 6 minus 2 mu, should be the same as negative 2 plus lambda lots of negative 5. So negative 2 minus 5 lambda, like that. So I'm proposing that if they intersect, I should be able to find a value of mu and lambda which is consistent in all three of these equations that I've written down. Okay, so it's just a game of linear equations now. So let's figure this out. I'm not going to use the middle one. I'm not going to use j because I've got too many unknowns, right? But I'm told in the question that these two things do intersect. So I can use equation 1 and equation 3. And obviously that would be equation 2. So if I use equation 1 and equation 3, I should be able to find a value of mu and lambda. Now, I don't know how you go about solving linear equations. There's a couple of different methods you can use, substitution, elimination, or just trial and error maybe. But I'm going to use elimination because they're not actually that bad. So let's get this right. So we've got 8 mu minus 9 lambda is equal to 6. So that will be my first equation. And my second equation would become, let's say, 2 mu minus 5 lambda is equal to negative 4. Well, okay, if I scale the second equation up, that would become, let's see, that would become 8 mu minus 20 lambda is equal to negative 16. And obviously I've still got 8 mu minus 9 lambda equals 6 in the second equation. So therefore, if I just subtract these two equations from each other, I get 0. That will become, well, be careful because I'm taking away a negative, that will become 11 lambda is equal to 6 plus 16, that's 22, yeah, which gives me lambda equals 2. Yeah?
No.
No? And then if I use lambda equals 2, I should be able to find mu. So substituting it into one of the equations should be able to find mu. I'm going to go for the second one. So if lambda equals 2, that's going to give me 2 mu, right down here, 2 mu minus 10 equals negative 4. Yeah, you happy with that now?
Yeah.
Perfect. Okay, which is going to basically tell me that 2 mu will be equal to 6, which means that mu has got to be equal to 3.
Mu is
3. Okay.
A is what?
So now I'm going to find A, right? Absolutely. So I found mu equals 2. I found I found mu equals 3 and lambda equals 2. I can now substitute that back into my second equation to figure out exactly what A has got to be equal to. So let me just write it. I'm running out of space a little bit. Let me just write it over here. So I'm just going to consider 3. So now I know that mu is equal to 3 and lambda is equal to 2. I'll have 2 plus 3, that's going to be 5, has got to be equal to A, which is what I want, plus 2 lots of lambda, so that's plus 4. That means that A has got to be equal to 1. Happy with that? Okay, so are we finished?
No.
Why not?
I mean, we just found the A value, which is the first part.
Exactly. So now we know that that value is 1. So I'm actually just going to replace that in there with 1. And I'm going to replace that in there with 1 as well. So the second part was actually find me this point of intersection. Well, actually, happy that's relatively easy. Because now I have a value of mu and lambda. If I substitute it into either my top line or my second line, I'll find my point of intersection. Okay? So let's use, just to show you get the same thing, I'm going to substitute it into both. But are you happy it doesn't really matter which one I use because it's a point of intersection? Find the same point on both lines. So just to show you I do get the same thing, but obviously you don't have to do this. So I'm going to use mu equals 3 in the top equation. That's going to give me my point R, or at least my position vector for R, will be 4 plus 3 lots, because that's my mu, of negative 8. So 4 minus 32, is that right? Nope, 24. So 4 minus 24, that's going to give me negative 20. 2 plus 3, that's going to give me 5. Negative 6 minus 6, that's going to give me negative 12. So I'm proposing that's my position vector. Just to make sure I get the same thing, let's try substituting with lambda equals 2 in the second equation. So negative 2 plus 2 lots of negative 9, that's negative 2 minus 18, negative 20. It's looking good. And then 1 plus 2 lots of 2, that's 1 plus 4, that's going to give me 5. Again, looking good. And negative 2 plus 2 lots of negative 5, that's going to give me negative 12. Okay? So that's my position vector. To be honest with you, you can leave the answer like that. I'm not going to mark you down. Officially, I want a point. So my point R is going to be negative 20, 5, and negative 12. So that'll be my final answer there. Are there any questions? So like I say, when you did that, you did not have to substitute into both equations. Just doing one is fine. But I'm just trying to show you that actually it doesn't matter which one you substitute it in, you get the same answer either way. Okay, so what variation of questions could I ask in this instance then? Okay, so let's suppose I give you 2 vector equations of lines. How many different ways can I sort of ask questions about this particular concept? Well, obviously here you can see an example of a question which I've given you. But to be honest with you, there's not really too much variation that I can give. If I tell you in this case, I'm telling you that the lines intersect, clearly we know how to solve this. Okay, so we've got an idea of how to solve it. But really, there's only 3 things that I can ask with this particular concept. I can either ask, show me that they are parallel. Show me that they are intersecting. Or I could ask, show me that they are, what's the other one they could be? So if they're not parallel, not intersecting, what must the other one be?
Not in the same direction.
Yes, skew. Yeah, perfect. So exactly right. So parallel means that they're bowing in exactly the same direction as each other. Intersecting means they must cross at some point. Okay, so clearly they can't be parallel, right? They can't be parallel unless you're intersecting an infinite number of points, which not really interesting. So if they're not parallel, so they're not going like that. They're not intersecting, so they're not going like that. The only other one is that they must be skew, right? They must be completely missing each other altogether. So to be honest with you, I might say a question like, here are 2 vector equations of lines. Determine whether they're parallel, intersecting, or skew. Or I might say determine that, or prove that they are skew, or I might say prove they are intersecting, or prove they are parallel. So really, these are kind of the questions that I'm centering around with vector equations of lines, okay? As long as you know how to do all of those 3 things, so show that they are parallel, intersecting, or skew, you're in business, okay? So parallel, we've shown how to show 2 vector equations of parallel. Just look at the direction vectors, show that they're scalar multiple to each other, right? If they're intersecting, well, we've shown how to do that. Set them equal to each other, find a mu and lambda, make sure it's consistent, right? Skew then, how do we show that one?
I don't know actually.
First, need to prove
is not parallel.
Yep.
Parallel. And then you need to prove.
They can't find equations.
Yeah.
Exactly. Yeah, so to prove skew, it literally means prove they're not parallel, prove they're not intersecting. The only other one must be their skew. So actually, there's only really two things you have to do, right? Parallel, do that. Intersecting, do that. If they don't work, must be skew. That make sense?
Yeah.
So actually, you don't have to do anything extra for skew,
Yeah.
right? Now, in terms of order which you should go about checking these things, so for example, if I say determine whether they're parallel, intersecting or skew, so I'm not telling you what the answer should be, I would advise always checking parallel first. Because parallel is the easiest one. Think about exams when you're under time pressure, right? Parallel will literally take you like a minute, right? So get that one done, get that one out of the way with first. If you're parallel, you're in business, you can move on to the next question. If it's not, check intersecting, a little bit more work, so you're having to solve equations and stuff. And then clearly if they're not parallel, not intersecting, they must be skew. Okay?